Hey everyone, MalaMaker here, and today we're going to switch it up a little bit on the tutorial, and we are going to get into Fusion 360. A friend of mine, I'm helping him learn Fusion 360, and he came to me with the Dragon Burner multi-head 3D printer and asked me to help them understand how to do the numbering on the tool heads to be able to allow them to have tool 0 through tool 5. And it was really interesting with the file that he brought because there are some componenting already done to the existing files. So I'll be working around that, but showing you a couple different concepts that you can use in Fusion to attack a few things. So we're going to get into it. To give you a little bit of background on me, I have been parametric designing for well into 20 years, a little bit over that, and specifically in Fusion, right about 9. I have a paid license with Fusion since a lot of the designs that I do create in Fusion are used for resell, and I make money on them, which ultimately that's where the license cost is necessary to be in compliance with Fusion. So anyways, that's a little bit about me and my background. Let's get to it, and I'll kind of walk you guys through it, and you can see a cool project as I work through it. So let's get into it. All right, so we're going to open our project here, and pretty much what we need to do is replicate the base of this tool head design and ultimately put numbers on each one of these tool heads. Now, the person that handed this to me, they had already done some sketches on this, and so ultimately what I'm doing is I'm just kind of cleaning up these sketches, putting everything I do at the right point in the timeline, because that timeline is very important, especially if you need to edit things. So ultimately here what I'm doing is I'm just kind of cleaning some things up. I am getting some measurements on the actual text box itself. And what I'm doing right now is setting hard values for the text box. Now, what I'm going to do here is actually select 2 points on this to align it to the corner so that on each one of these tool heads, the text is ultimately placed in the exact same location. So now what I'm doing is also setting the width to a solid width. And then here in a second, I'm going to show you how to use parameters to ultimately set the consistent values between each one of these sketches. Now, with parameters, it gives you a nice name to value kind of correlation. You can also use the actual tags that are automatically assigned behind the scenes to each text box. If you hover over them, usually it'll give you a D value on the measurement. So I'm setting these values. I'm going out here and actually changing the hard set value to that parameter value. Now, if I were to go and change that parameter, it would auto resize all of these text boxes. And now what I'm doing here is grabbing the value that was previously set on the text height, and I'm going to actually set a font height, which will then be used as a parameter in those text boxes for the font text height to where ultimately all 6 of them could change if you needed to tweak the value. All right, so we've done that. Now what we need to do is extrude this the same distance as those hexagons. So what I'm going to do is under extend type, I'm going to choose to object, select a surface or a point, and then you can see it extrudes out and actually also automatically hides the sketch. Now, with this, what I have done is I've put this already into its own component. So what I have essentially done is I've created a component, and then I've copied the body from the other component that tool head face comes from, and ultimately copied it into this new component. Now also too, you can see here I extended out the T0 to ultimately have its own text component. And when I extended it out, I did to a surface, and then I did where it creates a new component. And we did it in a way that ultimately creates a new component under that existing component that was created. Now, this is where you can do this in two different ways. I'm showing you how to offset that extrusion, and we're going to use two different methods here. The first method I'm going to show you is using the push-pull capability, which does take a little bit more work, but mainly the reason why I'm showing this here is to show you that there's lots of times in Fusion's more than one way to do things. So what I'm going to do is select all the surfaces around the outside on each letter or number, and then right click and do push pull, which is kind of like an extrude, but essentially what you're doing is you're saying, hey, I want to kind of keep this surface consistent with how it tends to be designed, and how if it were to be extended out in a way that kind of matches its existing profile. And what we're doing is we're offsetting that a negative 0.05 millimeters. And the reason why we're doing this is so that when we print this, we can print it separately or together. And if you print it separately on a non-multicolored 3D printer, it gives you a little bit of space where you have to do a little less work in trimming things down, sanding things to get it to fit into place. So now with the 0, we're doing that same methodology of selecting all the surfaces around the outside and offsetting it by that 0.05. And the same thing we're going to do on that inner circle as well. Now you can see this does take a little bit more time than what I'm going to show here later in the video as well, but it does offset it the way we want it here. All right, getting those finished selected, we're going to do a push pull. All right. And now we have our lettering, inset lettering offset. So now what we're going to do is take that body itself of the shroud and make it a component. And the big reason why we're making these components is so that we can export a single STL for each of the particular items that essentially would be used for 3D printing. So if you did want to use it in a multicolor 3D print, by doing this, the way that we're doing it, you can now export that component as a single STL. And then when you bring it into something like, say, Orca, and it says, hey, do you want to bring this in as essentially one object with multiple components? You hit yes. It kind of stitches them all together for you very easily. So now that we have all of those set, I'm just doing a little bit of renaming here to make it nice, neat, and clean. And you will see at the end of the video why I set things nice, neat, and clean. Everything's consistent. It also can be used for when you export these things to have your naming convention consistent when you export STLs, or for instance, if you export some sort of 3D modeling file like a step file or the F3D file that's Fusion specific. All right, so now we're going to select the top level of the tree. And now what we're going to do is create, we've created actually a few tool heads off camera. Now what we're going to do is we're going to create the last tool head of the mix, the T5. And this is where I'm going to show the other philosophy here. So what we've done is we've created a new component. We've selected that component. So we're working within that component. We found the body, which was body 1 under the T1 cowl component. We've copied it. We've moved it over the distance in which, or almost moved it over in the distance that we need. Need to bump it over another few millimeters here to get it in its place. So it's nicely spaced. And then from here, what we're going to do is, since there's an existing sketch that was already created, that sketch will then need to be essentially realigned to this surface. So in this sketch, since the person had already created all their sketches, we wanted to make sure that the sketches fall in the line in the right location. So what we've done is we created that component to kind of create a line in the sand in the timeline. And then we're going to go to the timeline and then kind of move the timeline cursor one back to then expose that sketch. We're now going to redefine the sketch plane. So since it's already existing and really its sketch plane was not in the, was kind of eliminated, we are now realigning that sketch to that surface. Now what we're going to do is move that text box that was created under that sketch and actually coincide it with that point that we did earlier in that similar location. We're going to set our widths, set our heights, set our text alignment. And then once we get all that set and we kind of get all those values and everything set where the way they need it to where it's consistent with all and using our parameters, then we'll get into the other way in which you can create that inset offset for the value there of the T5, for instance. So we got everything aligned. Now we're going to go down to our component, our T5 component, select it. So now we're working within this component. And what we're going to do is we're going to extrude it in, finding that surface. And now here we go. We've got our T5. So at this point, what we are going to do, and oops, it looks like we created some bodies here, and it should have, I believe, created a cut. So we'll go back and fix that. So we edit, we go down our timeline, edit our value, and then cut it out. So now we've got it cut out. Okay. So now what we're going to do is create a sketch on the T bottom surface of that inset. And now using your keyboard, hit the letter P. And what we're going to do is add the 5 to the sketch as essentially some reference points on that sketch. Then what you're going to use is use the offset tool in the sketch to actually offset those lines that are created by that surface by that 0.05 value. And now you can see we can then grab that inside drawing and actually extrude that out. And you can see this is much faster than doing the face offset. Face offset has its place, but for this particular one, doing this is way faster, a lot quicker, and just kind of cleaner in the end. So now we've, when we extruded it, we just said, hey, create a new component. And since we're working under a component, it creates a subcomponent under the component. Now we have both our body and our text inset here. And you can see that worked way, way faster. Now we can export this as one particular file for each. And then ultimately, like I said before, they can be melded together in your, say, Orca software that you may be using for slicing on a 3D printer. So anyways, I hope this helps you maybe organize things a little bit in your Fusion 360 projects and things like that. You can see here of the project breakdown under the browser breakdown under the tree. It's very, very neat and organized. Now there is another file of this that does implement the cooling fan locations as well. So you can see here I'm replicating the cooling fans within each component. That is ultimately becoming one file in the final file. And all of this that you're finding here will be available on printables.com and cult3d.com as well. So if you look up MalaMaker on there, you will be able to find both my printables and my Cult 3D on each respective sites. So if you guys are working on this and you want to implement a dragon burner, multi-head, tool head capability with the cat ears, this will give you that capability. And the final file does have it to where you can either print them separately or print them together. And it makes it nice and easy to print with. So anyways, thanks for watching. Make sure you like and subscribe. If there's more of these videos that you would like to see on Fusion 360, and I relayed things in a way that was helpful to you, please leave a comment. I'd love to get your feedback on other things you would like to see around Fusion. I've had a lot of experience with this, and I've done some very, very complex drawings and designs over the years. So anyways, appreciate you tuning in. Until next time, I'm MalaMaker, and happy making.